A least squares line finds a linear equation that best fits a set of data. The set of data will have two columns or two items that it's comparing. In life right now, there is a great deal of data being collected and used to interpret and then come to conclusions. This is one example of how we interpret data, and it's when all the data falls in what we could consider a straight line to forecast and predict the future. So let's start at the top of the document on the left. When data consists of ordered pairs having a linear graphed pattern, a linear equation called the least squares regression line is calculated. The method of least squares provides a means for finding the least squares regression line. Prior to technology, the least squares line was found with much work, and many students had difficulty with it as a lot of arithmetic was involved and error could be easily made. Technology today provides many programs and apps for determining the line, and I recommend students use technology and do not attempt to do this manually. There's an additional resource that I recommend watching on YouTube, and I've provided a link to it. It provides a good visual understanding of what the least squares regression line accomplishes and why the name least squares is used. The technology that I'm going to use in this example is from Wolfram Alpha. The example that I am going through today has data that is an annual average of 30-year fixed-rate mortgages. So for the year 2013, the average rate that was lended for a 30-year fixed mortgage was 3.98%. In 2014, 4.17%, and so on. I'm going to let x equal 0 represent the year 2000. That'll allow me to record the year 2013 as just 13. Okay, once I have my data, and I've determined that the left column in this case is going to be x, since the directions tell me that, and that the rate is going to be y, I come over to Wolfram Alpha or another piece of technology. With Wolfram Alpha, I need to tell the app what to do. So I write linear fit that tells the app to find the linear regression line. And then I write each ordered pair using parentheses. So 2013 is represented with just 13. Then I write comma and the rate 3.98. Close that ordered pair and place a comma right after it to let the program know that another ordered pair is being written. 2014 is written as 14, comma, and the y value or rate is 4.17. Complete that by writing all the ordered pairs, select the equal sign, and wait for a moment. On this screen, we will see that it has listed all the ordered pairs but with set brackets instead of parentheses. It tells us that it's found a linear function and that the least squares line or best fitting line is this equation. Now notice that it provides the y-intercept first and then the slope. This is a traditional way of doing it, and this would typically have a y equals or a y hat equals at the front of the equation. I transformed this equation into our standard slope-intercept form. So over on the left, I wrote y equals negative 0.131x plus 5.812. This is the y-intercept, and the interpretation of the y-intercept is that in the year 2000, 5.812% was the rate for the fixed year mortgages for 30 years. I know it's the year 2000 because earlier I had let x equals 0 represent the year 2000. Okay, so this is my least squares line that best fits my data. I can use this equation to try to predict what the 30-year fixed rate mortgage will be for the year 2017. It's a prediction, it's not an absolute. So in the year 2017, it has an x value of 17. I substitute this 17 in for the x variable and solve to arrive at 3.585. This means the prediction for the average rate charged for a 30-year fixed rate mortgage for 2017 will be 3.585%.